All right. Thank you, everybody. My name is Henry Liu, and I represent the Apple Maps DevOps engineering team. I have a number of teammates, maybe in the audience or at the conference today. I just want to thank them first, for all their hard work, kind of trying to solve dependency hell at scale. Uh, Today, I'm going to go over kind of our origin story, why we care so deeply about the dependency graph, and what we've done to kind of really move forward for our whole organization at that level. We primarily deal with JVM languages. We focus on data, big data, a lot of big data processing pipelines, and that really cascades itself pretty easily across our whole ecosystem. Uh, so I'll start with our origin story. What led us down this path, and including about how we've built the dependency graph, some of the challenges we hit along the way trying to build it, as well as all the detours we took trying to lead our way around it, and that led us towards building it out and finally diving into the developer productivity impact of some success stories after we were able to gather all that data. Finally, we're also exploring the concept of extending the dependency graphs into an infrastructure knowledge graph, trying to unify all of our worlds from CI/CD infra to production infra and beyond, joining it all together because starting from the build level, we have a lot of insights and a lot of information that is proves useful, right? All the way down the trail. As for our origin story, it starts with the very classic monorepo versus multi-repo debate. We've definitely leaned on the multi-repo side, but in reality, we're a really polyglot environment. We have smaller monorepos, distributed monoliths, multi-repos, and kind of everything in between. And because of that reality and the fact that teams have switched back and forth throughout the years due to various challenges, we've had to contend with both the best and the worst of both worlds. And that's really shaped our strategy as a platform team of how we approached it, trying to bring a monorepo experience to a multi-repo world and kind of have the best of both, depending on what our teams needed. And naturally, as we scaled in this approach, in the multi-repo approach, the number of projects grew and dependency hell crept in. Started slowly and then cascaded, and then it's full scale dependency hell. All of our metrics around happy developers and production issues and the like, skyrocketed and fell in the negative direction. And we sympathize with all our teams, right? And I'm sure all of you in the audience can sympathize as well. Trying to deal with this space, it's not a fun area to be involved in. And while we sympathize, the biggest challenge we had was that we couldn't get visibility onto the real root causes of certain, reasons that we had dependency hell. Was it a single library? Was it a single decision from a project team, a framework, etc.? Or was it just more cultural? And we would be chasing symptoms, debugging issues, and it was just really a long, thorough process that didn't really yield any results or any progress, right? Towards fixing the core of the issues. And with that problem statement in mind, we strategically decided, hey, we need to gain that visibility. We can't live without it anymore. There was no way we could survive, in the world we were in without having the data to back up and understand what was actually happening. First, let me start with a quick definition. What we invested in building was a data set that would map out relationships between projects. And projects in our world are a single source code repository, whether that's a monorepo or multi-repo. And generally, what we've seen is that projects can generate any number of artifacts, and consumers would pull in those artifacts and naturally would have a relationship between those projects. And it was important for us to go at the project and repository level because that was really the source of truth of where the original introduction of the issues came, right? We can kind of trace back all the way up through the graphs, all the way to, the first library or the first framework that introduced, these challenges. Maybe we would have a chance, right? And, kind of be able to navigate our way through all this bidirectional data sets. But as we were working on the earlier iterations of building our graph, we faced three primary challenges. The first was really just lack of uniformity. We were a very polyglot environment of JVM services running multiple software languages, multiple build languages, just trying to scale out the number of changes and getting consistent metadata across each was a little bit of a challenge, right, that we had to overcome. A second challenge was just really scaling out changes. So, Netflix just talked about it as well. How do we, globally roll out certain types of changes to our teams, right? To improve their life, to improve their productivity, quality, and all of the above. There are certain things that we can do at a platform level if we took a much more managed approach to rolling out and adding support. And finally, the most critical aspect and the primary challenge we faced is that data is only useful if it's accurate, up to date, and complete. We were in this polyglot environment and we had access to about 80% of our projects and 80% of our data, but we're missing that last little 20%, 10% of certain camps of teams running other languages, other Java languages, and the like. And we couldn't really, understand or get visibility into that space. And the risk there is that it could compromise the validity of our analysis, right? Maybe that's the root cause, or that's the project that's definitely impacted. Also, this could erode the trust in the data set itself, which is ultimately, the biggest thing we had to project to our teams. Hey, the data that we're giving you is accurate. It is complete. It is up to date. You should trust it to make your decision. With those challenges in mind, we took a multi-year detour instead. So what we strategically invested in was building out a centralized control plane. We ultimately took a shift towards a much more managed approach, a user experience that's much more familiar of the kind of the build and release teams and centralized build and release teams of a decade ago. We strategically took that because the culture of our organization and the nature of our projects really required 80% of our projects were pretty much identical, but because they had free reign and flexibility to do what they wanted, we were hitting a lot of scalability challenges, and we couldn't keep up with it. To achieve this vision, we abstracted the software development lifecycle into 4 phases: build, test, promotion, and deployment. And this really catered to a much more big data pipeline-centric software development lifecycle in the early days, which is kind of the origins of our platform, which is named Unified Build. And the goal there was to provide a unified release experience for all teams. Teams could jump project to project and get the same look and feel of a software development lifecycle and not have to relearn how to build, how to deploy, and how to do the basic promotion operations. And we were also able to standardize on Gradle as our primary build language, doing a lot of the orchestration behind the scenes. And with this abstraction in place, irregardless of software language or build language, we were able to predominantly converge on Gradle, as well as leave a little flexibility for the 20% to kind of fit into this abstraction and run in their world as well, so long as they met the contract of our standardized abstraction layer. Additionally, we made a big shift towards removing dynamic dependency versions. So we eliminated snapshots, we eliminated dynamic versioning conventions, and instead, everything is a release version. We built, I'll talk a little bit about tooling that we built around to kind of fill in that gap of the dynamic dependency world, but that was also a big strategic win because then we were able to add support, first-class support, for feature branch releases, which is custom to our framework for our platform for our teams. And that way, any team can be able to test, whether pre-merge or pre-code commit. And we built a lot of tooling and scaffolding around that to enable our teams to get a lot more feedback a lot faster. And overall, this control and standardization really allowed us then to scale out, right? We had full control. If we needed to, we can take an emergency override and take action. And we were able to kind of have full visibility and a consistent platform to be able to generate a lot of our metadata. And finally, it took about 2 years, we were finally ready to re-engage and rebuild our dependency graph. I think we finally had the control and the necessary tooling in place to easily scale this out. At the foundation of our dependency graph is data aggregated from Gradle Enterprise build scans. Predominantly, we're running Gradle, of course, and there's a ton of rich metadata, obviously, in both scans that you've seen, as well as access to the full dependency tree. And that was of key value to us. At a Gradle Build Summit, many years ago, that was my first introduction to Gradle Enterprise. That was it. We saw the UI visual dependency graph. We could run search inquiries on it, and that was the light bulb moment. There we go. We finally had a solution that if we could centralize around this implementation, we were good to go, and we can get the visibility that we needed. And also inspired by a previous talk as well by the Tableau team around generating developer productivity KPIs from Gradle Enterprise build scan data, we similarly built a streaming pipeline to extract the dependency info from our build scans. We stream all that data into Splunk, and then we're able to query, aggregate, and at scale, just give access to our teams to analyze and understand what is it that they're looking for. Our ability to roll this out came from a custom Gradle distribution that we built. So basically, we took open source Gradle distributions and wrapped it. We added an initialization script to it. We versioned and had release versions for Gradle distributions, and then we injected our own plugin at the bootstrap level, giving us full control to configure Gradle Enterprise URLs and configurations and whatnot. And obviously, from Hans's announcement this morning, we have work to do now to rename everything and roll out all these changes again. So it's a good thing that we have release versioning at the distribution level, so we can actually coordinate this and roll it out at scale locally. A second data source that we pulled from is GitHub, our primary source code control system. Here we were much more interested in a lot of the repository level metadata, repository names and such, but also commit info, languages, and additional metadata that is available at GitHub, right, in GitHub. Additionally, github.com has dependency graph APIs for third-party dependencies. So, there's another rich data source that we can pull from and aggregate and just gain more info to join together with all the build scan information that we do have as well. And finally, a third source is a more recent addition and one that we're most excited about. We've recently integrated SBOMs, short for Software Bill of Materials, which is gaining prominence in the software supply chain security space. And this is serving as a standardized schema, whether JSON or XML, for generating the dependency tree graphs at build time. We're definitely much more interested at the build time generation. So we're definitely interested in the build plugins for multiple languages and integrating at that level more so than the distribution level SBOM generation, primarily used for attestation or production type environments. And with this info, it gives us a lot of granular detail, right? It gives us access to even dependencies that are in shaded jars and whatnot, right? Because we know we are resolving certain versions during build time already. And that's where we really wanted to hook in, grab that data. And the big advantage of SBOMs for us is that it is cross-software language and build language agnostic in the JVM space. There's a lot of community investment right now to build integration tooling, CLIs, clients, and plugins. And that's really helped us scale out to cover the last 20%, get the data we needed in a consistent format that everyone can actually agree to because it's been made easy and there's a global standard. And that's really allowed us to complete the dependency graph. So even with our centralized control and platform, we still have this challenge of that last 20% or the one project that's not on our platform. But now we're able to kind of go down an SBOM strategy, an SBOM route as a requirement for all teams to be able to gain access to this information. Obviously, SBOMs have other usages as well throughout the technology stack. And this has been a big win for us and why we're so interested. Our success with dependencies led us a little bit further to go a little bit deeper into the build metadata space. In build scans and other areas, we also access the plugin dependency tree. And this is definitely an untapped kind of data source, in my opinion. Even for us, my own team as Gradle plugin developers, we were able to gather relational data between plugin usage and map that back to project usage as well. And this was kind of a big win for us to give us the visibility from a compatibility perspective, from a usage perspective, code maintenance perspective, and we finally had access to that information. Another much more complex and very fine-grained set of data and details are really what happens during dependency and conflict resolution during the build process, right? So naturally, Gradle has default conflict resolution rules. You can have advanced features to impact it and drive it, but kind of seeing what actually happens, having the audit trail at that granular of level can really help figure out why was a specific dependency version picked, right? Was it an override rule? Was it a conflict resolution rule, dependency substitution, you name it? And that really kind of gives a little bit more visibility into kind of the workflow of what impacted the decision. And maybe one of those were incorrect. Maybe one of those, made a major change or introduced a lot more, many more issues around that area. And finally, build time, build runtime. Obviously, you have access to commit level information, GitHub related information as well, and just gaining access to that, tagging that, kind of aggregating that at scale, just gave us a little bit additional insight on how to join all that info together with project level relationships, as well as other data sources that we might have. And with all of this data captured, overall, the dependency graph gave us a lot of actionable information. But to really maximize the benefits of all this newfound data that we have and all this visibility, we needed to build a number of utilities, frameworks, and tools to really go with it, right? The first is Automator. It's a very familiar tool for most teams, right? It's a very dependabot-like system for automating, generating pull requests at scale across any number of projects. And we don't use this just for software dependencies. And I'll talk a little bit more detail how we're leading into leveraging this kind of both push and pull model, push and pull from centralized control down to a decentralized distributed world where we need to impact and push changes downstream to everybody. Next are a set of custom analysis pipelines where we're processing, aggregating, analyzing the data sets. Obviously, there's a lot of room for machine learning and other technologies in this space as well to be able to get to the level of insights that we actually need. And we're able to kind of process and join all this information, serving it back up into our UIs and dashboards. And this is what we found, throughout all these years, our engineers never really understood dependency hell, dependency management, and the importance and the need for it until we were finally able to show them visually, right? And what we did is we picked, our worst offender, thousands of dependencies in the dependency tree. There were 10 to 20 of the same version of different versions of the same artifact and beyond. And we finally mapped it like, here you go, right? This is all red, it's spaghetti, right? And that really gave them, okay, yeah, we've been struggling. We understand now. What can we do? And that was what really kind of made a difference, that we brought not just the aggregate data, but the data back to the per project level, right? Where you're looking on a daily basis in your repo, what are your dependencies, what's your tree? We expose that level of information back to the users through our centralized developer dashboard, as well as multiple other aggregate dashboards where they could run advanced queries and really just explore the data themselves. And overall, that's where we've seen just a big win of understanding and awareness in the space. And now there's a much more a model where there's a lot more engagement, whereas before it was just us scolding teams or hey, can you change this and stop doing this and that, right? Cool. So now that we've talked a little bit about how we built the graphs and all the solutions that we went to go with it, we're finally ready to profit, right? We can finally use all this stuff. Let's impact available productivity. Obviously, that's why we're all here today, of course. Let's see some success stories. One of the major successes we've witnessed immediately was an increase in efficiency and quality when integrating between teams. So our dependency structure is pretty much a distributed monolith, so everything's tightly coupled. But generally our teams don't really talk to each other, right? Whether it's an API contract or boundaries of certain features and changes. That's where we saw kind of the first big gains, because they finally had visibility. Oh, I actually depend on your version of the code. What is the actual latest release version? What is what went in that code? What went in that release? And finally, we're able to kind of extract and provide a little bit more of a view of that information because we had the relational data for our teams. From a KPI and a metric standpoint, what we saw pretty quickly is that the number of support issues and production integration issues, typically due to runtime class path conflict issues, dramatically decreased. They were almost eliminated because we finally had visibility, and then a few of the other tooling options that I'll talk about next in processes, we were able to kind of really put some guardrails around our team and really help them integrate with each other, which it sounds simple in theory, but in practice, it was not great. So overall, what we've seen is just a dramatic improvement in the ability to make informed decisions. Previously, it was all guesswork. Maybe they're using my stuff, maybe they're not. They had no visibility into what was actively in use. So first is just really the producers to consumers view, of course, the natural, easy, scenario that we could provide to our teams. And now they understand, hey, who's using my library? Who's using it as intended? Who didn't I know about? Why is someone using my library? There's not even a library, right? And really that was the root cause of a lot of our issues when we did some analysis, that teams were randomly just picking off code and picking off libraries that were frameworks or other business pieces of business logic and treating them as libraries, which obviously then pulls in the rest of the runtime class path and led to a lot of our challenges. Next, the understanding the range of versions actively in use has really made a big impact for driving decision-making at the code maintenance level, right? Can we actually drop support for a certain framework or a major version? Can we actually make breaking changes? Why is somebody using an old version? And what this has really helped us do is just start a lot of conversations between teams. And that's been the biggest win we've seen. Teams actually can understand what's happening. They know what to do now for the first time because they have visibility, and then they're able to go connect with other teams, help them out, do what it takes at times to get to the finish line. Specifically, as our team also manages a number of Gradle plugins, this has been critical for us, right? We can understand what versions of Gradle every team is using, what version of our libraries and plugins are in use. We can deprecate certain things. We can make much more informed decisions that really simplifies our code maintenance and decreases a lot of the tech debt, spaghetti code, conditional code that we had trying to support, the whole world. And finally, another common question that we get is which project generates a specific library? So this is, an interesting question, and it typically we've seen arises when teams are troubleshooting or they've identified in their dependency tree, they've gone, kind of the L1 direction and figured out, hey, there's something here that I want to investigate a little bit further. I want to talk to the maintainer. I want to go look at the source code, etc. Where is this coming from? Where can I get more information? And with our relational data, we're able to provide reverse query and reverse lookups for these teams to be able to trace it back. So now we have the mapping of producers and projects and the artifacts they generated. And this is the type of info, in the past we would, hunt in POM files and the like and walk the trees and just really try to figure out where this all emanated from. Personally, in my own experience, I use this almost daily, trying to troubleshoot stuff across the ecosystem or just figure out what's happening or where all this came from. And having that audit trail capability has been critical in that. Another success story has been our impact to automating software dependency updates. So obviously, just in the talk right before, we heard some discussions around pushing changes to teams. So here we focused on internal dependencies. So obviously, you have Dependabot and other like systems for open source dependencies today. But what we really focused on was trying to shift left and speed up the integration lifecycle and feedback for our teams for integrating internal dependencies. So for all our library producers, even for us as Gradle plugin developers, this has been critical for us to be able to push and get that feedback as early as possible at scale, right? And then if we need to, such as rolling out this new Gradle distribution with the dev velocity change, we have capabilities now with our, automated framework, the data that drives as input for the whole dependency tree. We can just send it all out, validate, and get the status that, hey, everything's done. We're good to go. We can turn off the server, change the VIP, etc. So here we generate thousands of dependency pull requests daily. And, you have to be careful. You might DDoS your own CI/CD system, of course, if you're not careful, or, kick off a few too many releases all at once, right, of, the big bang type of rollouts. But this has really helped us, fix dependencies at the root level and make sure that they cascade across our entire ecosystem. So, whether it's a transitive dependency or any other effective change from a dependency health perspective, we can obviously patch it and fix it at the application level or the project level. But it's much easier if we're able to fix the root and get that propagated downstream so that we can remove all the complex conflict resolution rules and tech debt and complexity that you add on a per project basis. And then finally, we've also leaned very heavily into infrastructure as code practices for both CI/CD pipelines, all the runtime versions, Docker-based images, operating systems, Java, etc. And all of that is code now in the repositories themselves. And we're able to run, at high scale canary testing and infrastructure testing across all of our projects. So as an example, we were able to test a complete artifact store migration without any user interaction. We've got feedback, we understood the failure cases, we fixed the infrastructure, we added support everywhere, And then we just kept running these tests until everything passed. And then we merged it, turned off the server, and we were good to go. All of our users didn't even notice that we changed everything behind the scenes. So, this has brought us a lot more scalability at the infrastructure level, and, just piggybacks off of the same type of visibility and data that we have both at the build and project level through to the build and CI/CD infrastructure level, and eventually beyond is our hope. Another major area we've taken, and a final example, are gains that we've seen at organizational level software upgrades. These are kind of the multi-year or, once every couple of years type events, whether it's Java or Gradle or any of those types of framework upgrades that, if you've had to coordinate it for your whole division or your whole teams, or all your teams, it's painful, right? Not everyone is going to go at the right time. They're all going to, delay themselves. It just drags and drags and drags, right? And our incentive here to kind of drive these more thoroughly is just, the cost of maintenance on us at the CI/CD platform, right? If we need to support all the Java versions in the world, it's not a great experience, and we can't scale, right, at that level. So a few examples, we've actually made the decision to centrally manage and automate all Gradle major version upgrades across all of our projects. It's in our incentives because we kind of own the whole stack from distribution to plugins to CI/CD platform. And here we've just combined our canary testing capabilities, all the data we have from relationships between projects, and additional investments like code refactoring and rewrites and linting and things like that, to really just push for everyone. Gone are the days people are running Gradle 2, and we have to keep compatibility of some random plugin or some dynamic dependency. And, it always comes up at the worst time, right? Only when 3 years later, when there's an issue, production issue, and you're upgrading your build, oh crap, nothing works anymore. So we've kind of eliminated that challenge by just, dragging everyone with us. And, this kind of leans a little bit further back into, that centralized managed approach. There are certain things we can help aid productivity and by just automating for everyone, because, we have the experience and the expertise to drive this at scale. So what we've seen from a normal Gradle upgrade is obviously we'll do our plugin development and compatibility testing and whatnot. And once we're ready to start rolling out on day one, we're typically able to upgrade about 75% of our projects across hundreds and thousands of projects automatically on day one. And then we get the fast feedback on edge cases, regressions, bugs, right? Project-specific stuff. And by day 3, day 5, we're typically around 90%. So this has really just accelerated our ability to drop support and break compatibility and just throw away dead code, which has greatly helped us continue to scale. With a very small team investing in certain layers of our project. And lucky us, Java 21 just released as well, right? Obviously. So what we've seen here at the Java level is obviously with canary testing capabilities, we can actually understand what's going to break in our infrastructure. If we just change the compiler to Java 21 today or tomorrow, what happens, right? Are there JVM flags that are deprecated? Are there missing packages or runtime or just incompatibilities? We can kind of immediately get that info and that intel and feedback, and that really drives our decision-making process of how to add support and test all this stuff. Also, because we're able to generate ordered lists of relationships between projects from the dependency graph, we actually naturally are able to derive kind of a pseudo project plan for our project managers and our program managers to drive all of the teams and schedule them correctly, right? We can identify everybody depends on libraries. So libraries naturally need to go first, add compatibility, whatever strategy that we take to get to that level. And then let's schedule our application teams later. We can also give data and feedback back to our application teams. Hey, you're blocked on any number of these projects. They're not compatible yet. We actually know from the build scan and the dependency graph information. And then now we're able to, give them, actionable feedback. They can have discussions. Hey, we're blocked on this one. We can even identify complexity. Hey, this one library or project blocks hundreds of projects. Let's prioritize that. And that's been really a big win to really help us. It still takes a year or 2 years or, whatever the normal time frame for us, but we've been able to at least shorten it by roughly 6 months on average, kind of version to version at that level. And that has brought a profound impact to our infrastructure maintenance and scalability as well. And, it's just overall, just made life a lot easier for everybody involved to give them that fast feedback. All right. So, we've seen a lot of examples of how the dependency graph information and all this visibility has really helped us with dependency hell, as well as, other, scenarios that we've been working on. But what we're working on next is really trying to extend this dependency graph into an infrastructure knowledge graph, right? If we have this relational data at project and source code level, what's to stop us from joining this data set and these relations with other data sets at the infrastructure level, whether it's CI/CD, production environments, public clouds, etc. What if we just connect everything together? So to recap, our dependency graph is really just primarily focused on build level metadata today, build scans, SBOMs. But what if we connect dependency graph now with other common technologies that we work with on a daily basis, right? Database registries, application registries, contact information, issue tracking information, and then just that connectivity and that audit trail, even going to cost and deployments and production environments and beyond, right? How do we get traceability, auditability throughout the entire lifecycle back and forth down to a maintainer of a certain library or someone who took action to actually deploy this build? Obviously, there's overlap here with a lot of metadata and processes we have in our operational spaces, in our reliability teams and that. But what we're trying to kind of encourage our operational and infrastructure teams and reliability teams to do is really surface that data up, right? We've been hearing a lot of great talks about AI, machine learning, or LLM, et cetera. This is the next kind of untapped market, right, for a lot of this data that we don't traditionally look at or think of as data. So if we can extract this from the dependency and the build level, what's to stop us from grabbing databases and, the like and beyond there, and really give us a lot more informed decision-making capabilities at the infra level, which, if you've had to schedule downtime for a certain team and gotten pushback from project teams that, are worried something's going to go down in production, et cetera, now we have hard proof. We have definitive, you're not in the blast radius, you're not going to be impacted. You call this service or that project or whatever it is, we can finally push back a little bit and show and prove that, they can trust the data overall. Overall, we're still kind of evolving in this space. This is still kind of early. I think it's more about bringing awareness to our teams. We've taken the next step with SBOMs for build level metadata and kind of completing our data graph there. And now we're kind of socializing to a lot of our infrastructure teams and reliability teams to, hey, expose all of your data as an API. We're happy to scrape it and ingest it and pull it in because we have access to a lot of other interesting information that you're probably not thinking about, right? And ultimately, there may be overlap, of course, right? There's audit trail and whatnot in all the data sets. But you'll see that if you're able to connect a little bit more, you just add a little bit more metadata, and soon enough, much more advanced complex queries can be possible when you really need it. So I'll close with, in summary, some key lessons and takeaways for kind of our journey. And ultimately, it's been a multi-year journey. This was not overnight. We took and were inspired by a number of great ideas from Great Old Build Summit talks and just discussions with, the whole community in this area, and just kind of built, building a block by building a block, started connecting things, and kind of landed where we've landed these. So the first takeaway, and I can't stress enough, and for me personally, this has been a common theme across all of these talks today, is really just a focus on standardization. And this could be a monorepo, this could be a centralized platform, this could be a distributed, decentralized world as well. So long as that there's some level of abstraction or some level of standardization that we can all agree to, so that we can make and have this level of visibility. And better yet, if while you're standardizing, a centralized control plane emerges, that just really makes life a lot easier. We can push and take action when needed. Obviously, there's a social and cultural aspect as well. You have to develop a trust, you have to maneuver properly, you have to test this stuff, right? You can't just keep bashing teams over the head and pushing stuff and breaking their worlds. But if you have the data, have the visibility, have the tooling around it, and the capability to test, it all fits together, and then you're able to kind of work in this kind of managed model. Next is global visibility in a decentralized world, right? So, obviously monorepos are pretty prominent, right, in a number of areas. But for those teams not running monorepos, how do you gain access or get visibility into your 20% or, your decentralized world where it's a polyglot environment? there's no, I don't feel like we can ever go back, right, to not having this visibility. And we worked very hard for many years to really get to this point, even though everything was just incremental. And now that we have it, it's exponentially accelerated our capabilities, our productivity, our velocity, both at the engineering level as well as infrastructure teams and CI/CD platforms, and just everybody's a lot happier, myself included. Um, and providing audit trail capabilities backwards and forward, all the way from production down to source code repositories to maintainers to actual releases and code changes and commits, right? You can't live without that. And, the goal is how do we connect all that together to give the full view to everybody involved, right? Obviously, we have a number of teams in each part of the life cycle, from, development all the way through to production and beyond. But, you have to kind of build with that mindset in mind. You have to connect the worlds, right? Typically, teams are building for their, vertical over their space or for their use cases. But there's a lot of collaboration opportunities available if we just talked about it or took a look or gained access to their data, which, they probably already have. And finally, I think it's a term that Hans used this morning. Really, there's a treasure chest of metadata out there at the build level, the test level, the deployment level, and beyond. We haven't even tapped into it yet, in my opinion. And, I'm excited to see all of the innovations in the AI and ML spaces. I think this is the foundational data set that if we can standardize, aggregate, and, make it of high quality, that we can take, leaps and bounds just by, taking advantage of the basic capabilities that have been afforded to us now. So, at the end of our journey, definitely we have a lot happier developers. We have a lot happier infrastructure engineers and platform engineers as well, which is just as critical, I would say. And, overall, while we haven't completely solved dependency hell, we've actually, shown, given our teams awareness of the situation, given the tools, the data, the capability to work with it, to analyze it, to understand it better. They can always obviously come to us. We have capability and visibility for the first time to really go deeper and help these teams. And with that, I wish you luck in exploring all your data sets, and, look forward to hearing about your own stories, your ideas, your innovation in this space. Hopefully, by next year, teams that build frameworks and all sorts of stuff about this to make this a lot easier. All right. Thank you very much.